Everybody, I'm Addison Snell with Intersect360 Research. We are a small boutique startup analyst firm in the high-performance computing industry. The excellent presentations came before mine didn't, they summarized a lot of the things I would have talked about here. So I think what I can maybe bring are two things. One is my own personal perspective, having done an albeit services-oriented startup in the HPC space, and maybe more importantly, talk about some of the market dynamics that we see in the high-performance computing industry as it pertains to doing your own startup in the high-performance computing space. Intersect360 Research was started as Tabor Research. We were a group within Tabor Communications. That was almost 8 years ago now. Tabor Communications is the publishing company behind some of the titles in this space, like Datanami and HPC Wire. So we were part of that company until we separated 5 years ago. My partner, Chris Willard, and I bought out the Tabor research practice and moved it independent as Intersect360 Research, maintaining at that time a content and research partnership with the publication side. Since then, all of our relationships have evolved. We work with all of the other publications in this space now, and they've got other relationships as well. So these things evolve in this space, but we remember our heritage and where we came from. In terms of the reasons for going out and doing a startup, which Steve Campbell talked about earlier today. I agreed with everything that was on that list. He did leave one out. Desperation and terror are reasons that you move into the startup space. I never became an entrepreneur on purpose. We're just seizing opportunities that were in front of us. 2009, the year we separated from Tabor Communications, was not an easy one in tech in general, in HPC in specific, in service areas like advertising and market research in particular, where you're dealing with people's discretionary marketing budgets. It was a little thin, and separating out into our own company, borrowing a little extra money in order to survive was a way to keep going on and getting through things. We did the friends and family thing. We're Snell Willard Research, LLC, DBA, Intersect360 Research. Took a small family loan from the Snell Family Limited Trust partnership. We've done all of those things. And then we're in there every year swinging away, fighting uphill against established brands like IDC. And we have to carve out our market segment and come up with the reasons why we tell our clients we're doing things better for them. We can't do it exactly the same as the big enterprise brand who's in front of us, because then no one would ever buy it. So you've got to find out why you're different, why you're better, and then bring that to your prospective clients. And even then, you go into a large company, a large enterprise client, and after we get someone that says, we've seen what you have, we absolutely need it, we've got the budget, and we want to sign up. From that point forward, it's about 50-50 whether or not you'll get the contract. You got to get on the approved vendor list, you got to get into the budget cycles, and then you run into some analyst relations person who you've never met before who says, look, the fact of the matter is I've already got IDC, Gartner, and Forrester, and I'm supposed to fire one of them. So, it's just hard getting in there. You have to do the best you can every day, and some of the other small consulting or analyst firms who are out here have dealt with the same things. I know. It's just that kind of business. And we don't even have a product, which makes it even harder. I mean, we're just dealing with intellectual property. So, we have, I guess, copyrights, but not really patents or hardware or things like that you really need a lot of that very expensive upfront investment in. Now, HPC is kind of a funny market, as was pointed out earlier. It's a $30 billion niche market that's too small to warrant anybody's attention. It is a $30 billion market. Now, our view of the market when we're talking about the HPC space, we take a very inclusive view. You'll notice that we're counting more than just the servers, which are the blue bar at the bottom. I think if you add up the server components and call that the HPC market, you do the market a great injustice because there's a lot of other stuff out there, the software, the services, the networks, the cloud components that are all part of the external spending that forms this market that gets it to add up to not 11 billion but $30 billion in 2013. Furthermore, there are different use cases involved here. We're looking at more than just what you might call the high-performance technical computing part of the market, the science and engineering. We've always also looked at the high-performance business computing areas in non-scientific business applications for HPC, things like finance or media and entertainment, logistics applications, online games, and I'll come back to that on a separate slide. It is a, and when you talk about the total market, this is just looking at the external product and services spending. There's a different way to look at total markets, which is total budgets, and you bring in things that are internally spent items, most notably staffing and facilities. That becomes part of the argument if you're in a services-oriented area in particular, and you're going to consider that facilities budget or that personnel budget to be part of your total available market, or even if you have a technology that you're going to argue reduces administration costs or it reduces facilities costs. Now you're taking some of that internally budgeted piece that's not shown here, but you're bringing it back into your total available market. So if you take that more of a total budget spend, it's not $30 billion, it's $50 billion, because you're bringing in, well, more like 46, but you're bringing in all the facility spending, all of the personnel spending and the like. It is a growth market. It's not a crazy growth market right now. It's a steady growth market. It's, we've got it there in the mid-4s compound annual growth rate that's driven right now by the commercial sector, public sector, which a lot of people think about in high-performance computing, the government, academia. It's been pretty flat. Government's actually been down recently, and that's more than just U.S. government. That's looking at all the governments there are in the world that buy high-performance computing. There's not really been a geography where that's been good right now. You know, U.S. has had its own sequester problems, but you look at EMEA and the lingering Eurozone crisis. Asia-Pac is the only one that's had really pockets of, you see growth here or there sometimes, but not even that consistent across the entire geography. Some of the different ways we look at the market, we segment it by all those product classes. We do a lot of end-user research to try to get a triangulation around our market data. There you see that government budgets have been down recently. Academia was up a little, commercial's up a little. We see the business computing up more than the technical computing. All of the different product classes have been growing. Cloud has been the biggest one, going back up a slide again. Cloud's been the biggest growth, albeit from a small base right now. In as much as there's been a heavy emphasis on as a service in today's talk, that is absolutely true from a startup perspective. There have been two primary business models for high-performance computing in public cloud. One of them is the true new HPC user who hasn't done it before. There's a strong as-a-service component. You can do that you know, through someone like Amazon or Google or a more dedicated provider like an R Systems or a Cycle or somebody like that who really has HPC expertise. But from a total dollar perspective, startups don't consume that much of the market, right? By definition, you're dealing with low-volume people, so they just don't add up to that much on the overall chart. Down in the entry level, as a service is an important area. The other area where we do see public cloud spending is in certain cloud bursting characteristics where I've got occasional need for a significant amount over my peak capacity, and it doesn't make sense for me to buy that internally or wait. I'm better off bursting that out to the cloud. We do see that. 2014 is going to be the elbow year where, I don't know, you can kind of see in that orange sliver, it's been very steady the last 5 years, has not really been growing, but is about to start taking off. That's not just us thinking that, it's indicated in our end user research where we're starting to get the first major HPC end users who aren't down at that entry level, who are established high-end supercomputing users who are telling us, I'm going to spend 10% less, I'm going to spend 20% less on my next procurement and move the balance to the cloud. Not everybody, but just a few of them here or there, and that's the first time we've started hearing that, particularly in academia. And if I had to pick one commercial vertical market where that's happening, it's in pharmaceuticals. I did this slide already. Talking about high-performance technical computing versus high-performance business computing. This is a nomenclature that we've used for several years. I'll insert a little anecdote here that just occurred to me as I was listening to some of the other talks earlier today. One thing that I'm trying to insert our personal perspective as a startup here along the way. We've never been afraid of spending money when we think it's the right thing to do. We try to invest in things to try to fuel our own growth. But you want to do that in a way that you can afford it if it's wrong, and you also have to be able to get away from it fast enough if it's wrong. You can make affordable mistakes and on the balance keep going. This was one area where we've worked on how to talk about this with our clients for a long time. We didn't always call it technical versus business. When we started, we had traditional HPC versus edge HPC, and we've played with the definitions here for a long time. And for a while, we hired a dedicated analyst on the high-performance business computing side, someone who was a real expert in finance in particular, but also knew some of the other dynamics there. That was when we fleshed out a lot of this methodology a little bit better. What we found was our clients, our existing clients, loved it. They loved the extra work that they were getting there. They loved the methodology. We wound up keeping it. We wound up building on top of it. None of them was willing to pay us any extra for it. The idea that we had a separate analyst that they could talk to for that space, can we sell you a separate contract to look at the business computing side more? We weren't going to make any extra money. So eventually we had to let that analyst go, right, and figure out how to fall back and retrench on what will people pay us for. So it was good in terms of we built the foundation for it, and it wasn't like we went out of business doing that, but we paid a pretty senior analyst for a good while and didn't make any extra money doing that. That's the kind of, I'm not going to call it a mistake because we built on it. We did good stuff based on it, but we had to be able to get away from it. It wasn't going to pay for itself going forward in a long time. And one thing I've seen startups make mistakes in is not being honest enough about self-evaluation as you go to have a checkpoint and say, is this working, is this working? And not just do people like it, but am I going to make more money doing it? And if you don't, then you got to just cut it and get into something else. And if you're constantly making investments in things that you could afford it, and most of them pay off, and you cut off the ones that don't, then you can steadily grow. So that's one of the reasons I wanted to keep this slide in here. The other is just from the market research perspective of this notion of the transition between enterprise and HPC. You get a lot of these high-performance business computing vertical markets in particular that don't necessarily think of themselves as HPC markets. Now, the big banks, they do. The finance guys, don't kid yourselves. They know they're doing high-performance computing. I remember the year Morgan Stanley poached a team en masse from AT&T Bell Labs. They just went in and said, we'll take you 8, right? and move them in to take over the strategy. And that was not recently. The finance has been around this space for a long time. It is the faster growing area by a little bit. Financial services, here we're looking at applications not just in high frequency trading, but in risk management is actually the biggest, fastest growing, most interesting area. The large scale Monte Carlo simulations to maintain your risk positions, trying to move that to intraday positions, real-time positions. Online games, here I'm talking about the massive multiplayer online games. We have servers behind them that have real-time I/O requirements, because if I'm playing my game and I try to jump around the corner and fire, and there's a half-second delay before my avatar does that, and in the meantime I get dead, then my gaming satisfaction starts to dwindle. So in as much as a lot of that rendering is pushed off down to the client side, there's a real-time I/O requirement on the server. Ultra-scale internet, the big purple wedge there, is the one that we need to develop a little more. Those are the supercomputers that in our nomenclature, they're not really doing HPC applications other than the level of scale at which things are being done. In particular because we've been tracking it as a high-performance business computing market, and it doesn't really fit there either. Going forward next year, we're going to move it out as a third separate circle. It has its own industry dynamics that are a little different. The other thing about it is we've come to the realization this year that we've got it too small. You'll see a significant resizing of that from us next year that will grow it substantially. I'm not willing to commit to a number yet, but I'm confident in that because we've come to the realization that we were undercounting some of the Chinese components to that market. Baidu, Tencent, Alibaba were not really part of our model there when we did it the first time, and they need to be in there. So you'll see a growth, a discontinuous growth in that as we model those in. From a startup perspective, if you're looking at this in terms of where your segments are, first of all, just because you're in the high-performance technical computing market doesn't mean it's all science and academia. There's a lot of commercial vertical markets over there, engineering and pharmaceuticals and oil and gas. These are commercial companies that are doing engineering. You go over to the business computing side, you might have to ditch a little more of the HPC language. You're talking about it in the language of the vertical market that you're talking to, right? So if you're talking to a bank, you shouldn't be talking about HPC as much as you should be talking about maybe value at risk or tranches or things like. You've got to really have a business development person that speaks the language of that application, and that's an investment you're going to have to make. The ultra-scale internet segment I was just talking about, I also like to call it the Chuck Norris segment. You don't go and find it, it comes and finds you. It is very, very difficult to intentionally sell into the ultra-scale internet market. But if you have a cool new technology and that it's out there, people are aware of it, they will come find you if they're interested. Google bought the company Peakstream, 7-8 years ago. That's a great example of Google just taking a company that we were tracking as part of the HPC market and bringing it inside to Google, and then no one else ever heard of it ever again, right? They're just using it internally and keeping it away from other people. That's the kind of thing that a company like that is quite capable of doing. So from a market trend perspective, major trends to consider. Big data has to be at the top of that list. Out of all of the buzzwords that ever came through the high-performance computing market, big data is the one that has the most actual money, actual spending, actual trends tied to it that are really going to move the market in a very meaningful way. Now, there's a lot of ways to look at, well, first of all, it also feeds into a lot of these other trends. You know, cloud increases accessibility to data. Mobile or Internet of Things increases creation of data. Mobile increases both, the creation of data and the accessibility of data. So any of these trends have a play underneath the big data methodology or umbrella or whatever you want to call it. So it's this great overarching thing where it ties in HPC, it ties in all of these other big trends that VCs get excited about. Personally, we think it's a mistake to put something like HPC entirely underneath big data. And similarly, we think it's a mistake to put all of big data entirely underneath HPC. They are not the same thing. You know, to see new supercomputers go into Oak Ridge National Labs and talk about them as big data machines, I think is folly, okay? That's a supercomputer. It can be a supercomputer. It's not that there aren't petabytes of data going into that, but that's not really what people are talking about with big data. Don't over-confuse the terms. Yes, any supercomputer has to deal with data in new ways at higher volumes than they've ever done before. But don't conflate the trends entirely. And similarly, you get big data people who are saying, well, this is all entirely new and has never been done before. No one else has seen an application. That's equally arrogant in the opposite direction because it fails to appreciate that there are technologies that have been nascent in the HPC space for decades that have applicability to big data. They don't entirely cover the space, but you ought to look at it, right? When do you really want HDFS versus an established parallel file system in the HPC space? There are different application characteristics where you should really be looking at What are the technologies that are in play here? Anyway, the reason that I'm spending so much time on this bullet is when you go to people who have big data problems, which is to say there's a sample bias here. Do you have a big data problem? And people opt into the survey. Take that set of people. And now you ask them what % of their IT budget is going to big data. Well, there's a range, of course, and it makes roughly a bell curve. But the peak of that bell curve is like in the low 20% range. Percent of my, not percent of my HPC budget, not percent of my storage budget, percent of my IT budget is going to big data. That's an awful lot of IT budget out there that people are saying this is tagged for big data. Now, it's also weird, though, because notice that I don't think anyone's claiming enterprise computing is taking off at some 20% clip. Mostly what that is repurposing of existing funds. And in particular with big data, a lot of it started as grassroots efforts. People are not rushing out to buy all new big data infrastructures right out of the chute as much as they're taking data they already have on storage they already have, on servers they already have, with people they already have, and saying, can you go run some analytics on this in time for the staff meeting next Thursday, right? Because the CTO wants to hear something. That's how these big data initiatives are starting. It's primarily not been Hadoop. It's been primarily in-house applications, algorithms, queries, takes up half of it. Then Hadoop takes up most of the rest. People have migrated from doing in-house to Hadoop increasingly over time. I'll get to it, Steve, but let me keep going. And that will evolve. I kind of think of it as like the early days of ERP systems, which was entirely an enterprise thing, not so much an HPC thing. But if you think back to around the year 2000 when ERP systems were new, the first couple years was the Wild West, man. That was, ERP was a consulting-led, multi-million-dollar effort that was only for the largest enterprises. It would take 2 years before you had anything that was working. After about 3 years in, you started getting, here's some established solutions. It was still expensive. It was still hard to do, but a few more people could do it. By the end of 10 years, it was just a software package you go out and buy. Everybody had it. Big data is going through that same kind of transition. We're about at that 3-year mark now where you're starting to see some really, your first package solutions from established vendors where you can go out and buy a big data package of some type. Now, big data in itself isn't a technology or a particular application. You don't go out and buy a big data, right, or an application that does big data. You can buy analytics or MapReduce or graph or different kinds of things, and you're starting to see those kinds of solutions now. Cloud, I already kind of talked about. This is absolutely a major trend to consider because it increases the accessibility of resources to more people. And in the entry level, if what you're doing is talking about saying, I can improve your access to high-performance computing technology using cloud as a component, then absolutely, I'm all for it. But cloud for the sake of cloud, it's not like people haven't heard of cloud at this point, right? A cloud in of itself is not a value proposition to me. Cloud is a delivery mechanism for how someone might get access to services. Where we're seeing a lot of it is in that entry level where the value proposition isn't cloud. The value proposition is something like engineering services, right? I can go to a small manufacturer that maybe is doing CAD or CAD-CAM on the desktop. They've never done CAE on a cluster before. And I've got a services organization that can take your CAD models, turn them into CAE models, and then help move them into the market. Was that a time warning you were giving me? Okay. Entry-level HPC adoption is what I was just talking about there. Evolutions in storage, there's a lot going on in storage right now. Big data has a lot to do with it, but we see movement in file systems, we see movement in flash, object storage, data-centric computing architectures. The problem with this part of the market is it's really, really boring. It is really hard to get people to listen to your great presentation on I/O throughput and your new object storage technology and data migration. Your VC's eyes glass over. They completely trout, right? You're 4 minutes in and your VC's just going like this, right? And you have to reboot them or something. It shouldn't be like that. At some point, storage got disassociated from high performance computing. Like you point to your racks and racks of compute, and that's my computer, and that's awesome because it makes my stuff run faster. And then you point to your racks and racks of storage. What's over there? Oh, that's just the storage. Those are my disks. Whatever happened to, if I have access to the data faster, the computer got faster, right? That ought to be, that's not that long a walk to upgrade your storage and say your computer got more powerful. At the laptop level, the disk is part of the computer. Why does it get lost when you go to HPC? Finally, and a big point I want to make is there's a lot of opportunity coming from the fact that we've really entered a new era in high-performance computing. You can look at the different historical vectors and the historical era, and it feels like they segment well, and you forget that there's always sloppy transitions between them, that you go from vectors to RISC-based SMPs and Unix, from there to Beowulf clusters. Really notice that we are now at the cutover to a new era, which is the multi-core, many-core era. And it's different from the Beowulf era. Now, what they all have in common is every time you take one of those steps, there's a massive undertaking to re-optimize or report codes because the code models are not the same from one to the next. Multi-core and many-core is another era where people are going to have to completely report or re-optimize their code to some other type of model. It makes for a lot of movement in the market. It has in common with all of the other eras that there's a democratization in a sense of high-performance computing, and that there's a lot more flops available for a lot less money. I can go buy all this great computing power for less money. The difference with this era versus other ones that you have to get across, though, is the notion of an industry standard cluster or a commodity cluster, which has really been important in some of these other eras, especially Beowulf, starts to break. I don't know what an industry standard node looks like anymore. There's so many different competing architectures here that the challenge for the end users is they don't know what they're optimizing for. And that also creates opportunities for a startup if you're comfortable with the idea of segmentation. What application areas am I going after and what can I do for them? So the challenges of HPC startup, they're hard to explain. You need to focus on the application, the opportunity, put them in context of some of these larger trends. It can look like a small market. You have to put it in context of these larger trends. These are all things people have been saying. They're high stakes. You know, these things aren't always cheap. Getting into the budget cycle, getting people to plan to buy your thing can take a long time, and it's more than engineering. You've got the better product, but you need all of these other things that are part of the other presentations today. Being able to do the legal, the accounting, the sales, the marketing. Believe in marketing, by the way. Marketing actually works. The dirty secret is that I'm a no kind of engineer. I actually have an MBA. Right? Which is the worst thing to have in this kind of industry. But having a business appreciation of how to bring stuff to market is enormous. Marketing actually works, and you ought to invest in it. That's it. Thanks very much.